Well, hello and welcome to the first video in a series of 3 videos that I want to prepare for you related to some key factors and some engineering study that we can do about propane. And so I hope that you recognize this. For those of you that have been camping, you may recognize this is a small bottle of propane. You see that use it for old school lanterns, but certainly probably more modern day, going to use this small propane tank for small grills. Maybe even seen tanks like this at tailgates. So let's get started on the first module. I am a little rusty at doing this. Sorry about that. So here we go. Propane tank demo. This is going to be video number 1. You see a number of familiar images. Of course, this is going to be what we're going to analyze, just the Coleman small little propane tank, but some of you may be familiar with, here's a 20-pound propane tank that's used for home residential use for gas grills and other applications. And here's even larger propane tanks for residential heating and cooking. All right, let's overview the 3 modules that I have in mind for you. This first one, what I'm going to try to do is we're just going to look at some real world situations to identify when is this an open system and when is this a closed system. We're going to go through and try to determine the mass of the propane that's in here. We're going to try to determine the volume of the propane in here, and then ultimately find the specific volume, which you're studying about from your text. The second module will be, we're going to try to figure out what the pressure is inside this tank without using a pressure gauge. It's going to be kind of a cool introduction to chapter 3, I hope. And then the last module is looking all the way ahead, probably to the last week of your class, chapter 13, which is going to be some combustion basics. So that's the overall roadmap of all 3 of these modules. Okay. And so in this module, we're going to cover basically what's covered in chapter 1, measuring mass and length, which ultimately will be the volume, and then determining the specific volume. Okay, so what's inside this tank? This thing that I hope that you've had some exposure to, that you've used in your life. Well, let's see. Propane. What is propane? Now, I'll have to admit that off the top of my head, I sometimes do not totally recall that propane is chemically C3H8. I've done it enough now, refreshing my memory on propane. I think I've got it back in my head, but I had to look up when I first came back to teach thermo again after 30 years off. I had to look in the book to verify that propane is C3H8. And then, of course, here is the molecular sketch of what propane looks like. I hope you've seen propane trucks driving around for delivery and selling of propane. I hope that you're familiar with how gas grills work. And then here's an example of propane supplied sort of restaurant heaters for outside dining. These are really cool radiant heaters because that propane flame is so hot. You get radiant heating when you're dining at this table. So that's a little background on what propane is. All right. Now, think in your mind, how could you determine the molecular weight, also known as the molecular mass, the molecular weight of propane, C3H8, without looking it up in a book? Could you figure it out? Think in your head. Could you figure it out? My answer is, I sure hope that you could. C3, I remember from high school that the molecular weight of carbon is 12. So that's going to be 12 times 3 plus molecular weight of one hydrogen, 1 times 8. So it's going to be 3 times 12 plus 8 times 1, or the molecular weight of propane is 44 kilograms per kilomole, and that's equivalent to 44 pounds mass per pound mole, depending on the unit you're working in. So my little yellow text box that I hope you're going to have to deal with, get used to. It's kind of like yelling at you, my yellow text boxes. You should be able to do this without a formula sheet or without visibility of a periodic table. You should be able to calculate the molecular weight of propane, as long as you know that it's C3H8. How about CH4 then? Could you determine what's the molecular weight of methane, CH4, natural gas, without looking it up? I hope. Okay. So let's see. Oh, here's our objective for this module. Determine the mass of what's in this bottle, okay? And then determine the volume of what's in this bottle, and start with a sketch. So when I go live, I want you to think in your head, if I had to draw a sketch of what we're doing, if this were a homework problem, what would my pencil and paper sketch look like for this situation? So I'm going to bust out of here. I'm going to stop sharing. Okay, so I'm hopefully full screen now, and determine the mass. How will we determine the mass of this, of what's in here? Now, let's see. I'm going to shake this a little bit. Okay, of course you cannot hear it. It's very subtle, but I can hear it close to my ear. There's some sloshing going around in this tank. I can hear it. I can hear some sloshing. All right. Now, I've also got because I've done a lot of demonstrations, I've got another tank here that's all used up. And when I shake it, I don't hear anything. Now, it's my guess that there's still some gaseous propane in this tank. I hope to be able to demonstrate this to you at the end of the video. I don't hear anything. So if there's anything in this tank, it would only be a gram or two of gas. Okay, so basically I've got the weight of just the tank, and I've got the full weight of the tank plus the propane. All right, so what do you think? How would we determine the mass of this thing, of what's inside the tank, by still leaving propane in the tank? Okay, and you think, well, let's see, how would we do that? I happen to have prepared, I've got a nice electronic scale here. I got it from Gander Mountain. It's an electronic fish scale, but it's going to work great for our application. And so let's see, how would we do this? If I get the mass of the empty tank, we'll call it empty, okay? And then I get the mass of the tank plus the propane. It does not take a college student to figure out that what we'll do is by subtraction, we'll figure out what's inside the tank. All right, so how do I do that? I have come up with this ingenious method. Look at this. I've got a Kroger bag. All right, so I'm going to put my tank in the Kroger bag, empty tank. I'm going to turn on my scale. I've got it selected to kilograms. Okay, and I don't know if you can, I think you might be able to see it's reading 0. Okay, I've got a number, and that number is 0.42 kilograms. Write that down. Okay, I re-zeroed. All right, so that was my empty tank. All right, now I've got the full tank of propane. I've got the full tank of propane in here, and here we're going to start again. I'm at 0. Okay, let's see. I've got 0.87. Okay, write that down, 0.87 kilograms. Okay, so we've got two numbers, and we're going to subtract those numbers from each other to get the net weight. All right, the next thing we got to do is the volume of the tank, All right, so let's see. This isn't kind of like research. This is engineering, problem solving right now today. So I've got the tank, and I've got my ruler from provided to me by Procter & Gamble in 1976. Okay. So all I've got to do is measure the diameter and the length of the tank, and I'll use math then to figure out the volume. So let's see. Bear with me here a second. I've got to estimate the inside diameter of what's inside this tank. And I'm going to do that here live. Okay. And okay, I'm looking at it as best I can tell. I can only look at the outside of the tank. So I have to just sort of eyeball and imagine the thickness of the steel tank. And I'm doing that in my mind. And my best estimate for the diameter of the tank is 9 centimeters. 9 centimeters. Okay, so you see what 9 centimeters looks like. All right, and then the length of the tank. Now, so clearly this is not a pure mathematical cylinder, isn't it? So I've got to sort of eyeball about where's the end of my start and end of my tank. And so I'm going to do that. I've got to make some engineering judgments. Okay, very typical. You're going to be expected to do this, not necessarily in this class. You're going to be given input data, but clearly you get out in a job, you've got to make these decisions on your own. Nobody's figuring this out for you. And so my estimate for the inside length of the tank is 15 centimeters. 15 centimeters. So you could write that down too. So now let's go back to doing some calculations. So we've gone live. We've got 2 mass measurements before, empty and full. We've got enough to get the volume. So start with a sketch. If this were a homework problem, I hope your sketch in pencil and paper would look kind of like this, kind of professional looking sketch. Here is I'm depicting my vessel, a closed vessel. I'm depicting the control surface with a dashed line inside it. That would be the propane. That's our closed system. I've labeled it C3H8. I'm looking for the mass and the volume, and I write down with pencil and paper. I'm going to write down closed system. When you get a quiz or a test, write that down. That's worth something. Okay, closed system. And I also write down rigid vessel. So do you see that this vessel cannot change its volume, can it? It's a constant volume surface. Okay, no way I can change this volume of the tank. Sort of in the real world, right? Some people say, well, if you charge this up to 10,000 pounds per square inch, the tank would expand some. Well, 10,000 pounds per square inch would bust the tanks, but you get the idea. Rigid vessel, closed system. All right, so we're going to do the math now. Physical measurements. We measured the nearly empty tank mass was 0.42 kilograms. The full tank, steel tank plus the propane, 0.87. So by subtraction, we've got 0.45 kilograms of propane in our tank. That's M, that's little m, that's the mass. All right, the volume. The tank inside diameter, 9 centimeters, tank height, 15 centimeters. Let's see, that's pretty straightforward. The tank area, pi over 4d squared is the area times the height or width. And that's going to be 954 cubic centimeters with my units. And so you have to think ahead. Now, what do I need to do to go from cubic centimeters to cubic meters? I've got to divide by 100, divided by 100, divided by 100, or in other words, divided by 10 to the 6th to get my tank volume, capital V, is 9.54 times 10 to the minus 4th cubic meters. Okay. So as a reminder, what's M? M is a property. M is a property of this closed system. It's an extensive property. And the volume is an extensive property. It depends on the size of the tank. The volume depends on the size of the system. Now, just by the way, I've got a picture of your brain, thinking, how accurate are these values? So notice here that as an engineer, I'm only putting down about 4 significant figures on the tank volume. As best I could, I measured the tank height in centimeters, right? Not in millimeters. So the accuracy of this analysis, it kind of depends on your engineering objective, right? So we're not doing some detailed research project where people's lives depend on your measurements. We're just trying to get an answer of how much is contained in this propane cylinder. So be aware of accuracy. So notice here how I'm expressing sort of my answers in up to 4, anywhere between 2 and 4 significant figures. All right, let's move ahead. Let's determine, whoops, wait a minute. No, I think I've got it. Did I cover everything on that slide? Yeah, we took the difference in the two mass values to come up with what our best estimate for the mass of the closed system propane. Yeah, 0.45 kilograms and a volume of 9.5 times 10 to the minus 4th cubic meters. All right, so the next problem, how about the specific volume? This is where you must do your textbook reading. This video is not intended to cover all of chapter 1. I'm just giving some example problems here. All right, so what have we got? We've got the tank volume is 9.5 times 10 to the minus 4 cubic meters. And so we've got the mass, and it looks like I didn't, in my screenshot of my little Excel file, I should have clipped the mass as well, but you can see that we're going to take V divided by M to get the specific volume is 2.12 times 10 to the minus 3 cubic meters per kilogram. So if this were a homework problem for you, don't put down 8 significant figures. That's false accuracy. So for this class, about 4 significant figures is probably about the most you want to be working with. And so as a reminder, little v, notice here, look at this, little v, that's specific volume compared to capital V, which is volume. So the specific volume is an intensive property, cubic meters per kilogram. So for my example, if I could take a little sample at 100 places within the closed system, I would get the same result, the same specific volume result if I were sampling within the closed system. Okay, there we go. And the mass, let me go back a slide. So I'm having a little mental lapse here. The mass of our propane was 0.45 kilograms. Now, how about if I check my work? If I check my work, so this is a nearly full sort of as store purchased thing. And let's look on the, what's given. What did I buy? What did I purchase? And it might be a little blurry, but it does say 1.02 pounds, 1.02 pound mass. And that's it. So that makes sense, doesn't it? Because there's 454 grams in a pound, okay, or 0.454 kilograms in a pound. So I'm feeling pretty good that my little experiment is right on track. Okay. We got the specific volume done. All right. Oh, okay. So now let's demonstrate an open system. How would I've got this nice tank here. How would I demonstrate an open? So how do I turn a closed system into an open system? So you're gonna have to excuse, let's see, I'm gonna put this nozzle on here. Okay. So I've got a little propane burner tip. Okay. I'm gonna, yikes. I'm going to light this off, so I got to keep it away from my face. Okay, so now this, what do we got here? We still have a closed system, don't we? We've got a closed system. When I open this valve, it's going to be an open system. So here, I'm going to open it. I'm going to crack it open. I've got my spark to light it off. I don't know if you can hear that, but it's blowing. Okay, so here is to demonstrate. We've really got propane in here, and it's really, there we go. So we've got a real flame. Now, I'm not going to run it long because I don't want to decrease the mass in my closed system. All right, so there, I just closed the valve, ran out of gas. All right, so now I'm back to having a closed system again. I did have an open system with, and let's see, how many inlets did I have to my open system? There was nothing going in, nothing was going in and one thing was coming out, propane, and the propane was combining with air. So do you see some engineer designed this nozzle so that propane comes out of this part, and then air, atmospheric air, is entrained in these little holes. There's a set of 1, 2, let's see, 1, 2, 4. There's 4 holes where air is entrained. So the propane and the air combine. I lit it off with my spark and got the combustion. So a good example of the real world burning. All right. So we demonstrated, so back to share screen. Okay, so recap. Here's my depiction of an open system that we just saw. Open system, I wrote down in my sketch, no inlets and 1 outlet. That's going to come in handy for you as you go through the course. And inside the system is C3H8 propane. And I showed M dot. That's not mass, that's mass flow rate. When we put a dot in this class, when we put a dot over things, that indicates a rate. And so when I was doing the demo, you saw the propane coming out, you saw it being burned at some rate, some kilograms per second, a tiny little number, but it was a mass flow rate, M dot. All right, so get that in your head. You got to get that in your head. No formula sheet's going to save you in understanding what M dot is all about. All right, so we are at the end of this module. So here's some points I'd like to make. The fundamentals. So we just covered some fundamentals here, and I'll bet you a lot of it was Common Sense 101 that you've already got in your head. You've got this in your head already. But for these, the fundamentals are going to build all the way from chapter 1 all the way to chapter 13 of combustion. Suggestion, putting in good upfront work is going to pay off for you throughout the course. So these chapters are not standalone. So you say, well, I'm going to bust through, I'm not going to mess with chapter 1 because that's just chapter 1. That's not a good way to do it. Each chapter builds on the previous chapter. So I really want to encourage you to put in especially some hard upfront work so that you'll build a fundamentals foundation for yourself as we go along. And so looking ahead to the next video, how much liquid propane and how much vapor is in this tank. So I can hear something sloshing around in this tank. So it must be some liquid and some vapor propane. And so that's all about chapter 3. And so we're going to get you ready for chapter 3, or you'll watch video 2 when you're working on chapter 3. Okay. Maybe a little clunky for me to kind of get back familiar with refreshing my memory on doing these videos, but that's it. I hope you've gotten something out of this, and hope you join us for the second and third video about propane.